We are working on putting wing sails on ships. It's a little bit like an airplane wing that we put up in order to generate as much thrust as possible. And of course, a lot of background to this is for sustainability, to reduce emissions, to reduce the dependency on fuels and also new fuels and so on in the future. So we want to create a ship where you can have less dependency on those things, and also for the environmental sustainability.
Wind-powered shipping. Even more multi-million-dollar funding for wind propulsion projects in Europe. This one with a 40-metre-high retractable wing sail design as part of an overall ship design concept that is promising huge steps in reducing fuel dependency in the future, either fossil fuels or even more expensive clean fuels that are under development. Hi, I'm Craig. I'm host of the RNX podcast and editor of the Fathom World news site. I spend my days as a journalist looking at the changing shape of the shipping and maritime industries, at the technologies, the people behind them, at the environment, and at sustainability. Before we hear more about plans for giant retractable sails on car carriers, I want to turn to those new fuels that are set to come into shipping in one form or another. Whether it's ammonia or methanol, whether it's an electrofuel or a biofuel, whether it's a fuel we've yet to talk much about, they're all going to be expensive. So where's the incentive to be a first mover? And let's just assume for a second that there is great success in getting industry to decarbonise quickly. Just how will we make sure officers and crew know what it is they are sailing with? First, the incentives to go green. And let's assume we accept that huge changes in the industry need to come with huge investments, either through increased capital costs or operating costs, or both, and that those that can make the move want to reduce the risks of the investment. Big shipping companies have an opportunity to turn the tide, so to speak. They can make the investment in new technologies, such as what A.P. Møller-Mærsk's Maersk Line is doing with its methanol-powered new buildings, and apparently what Höegh Autoliners is doing with reports that it's upgrading the last 4 of its 9-vessel new building program to go directly to be fueled by ammonia. But how can these vessels, for example, be run if customers, the cargo owners, don't want to pay a premium to put the cargo on that vessel? And then what about customers that do want to pay a premium and do want to demonstrate a clear effort in reducing Scope 3 emissions, which, by the way, they will soon find themselves having to do? How do they, the willing cargo owners, find a clean vessel if there are none available where their cargoes are being shipped to and from? There's one possible quick answer to this, and it borrows from a process which can be found in the electricity markets and also in aviation. It's called book and claim. The basis of the idea is that a clean fuel or clean energy provider books a certain value of emissions or clean solution and a reduction into a system, and another entity can then claim the benefit of using it. Taking this into a shipping industry context, a ship owner who runs a vessel with a clean fuel would book the clean fuel into a system, and then a cargo owner would claim the actual specific reduction in emissions, even if the cargo owner's cargo is not on the ship in question. But is this just another form of an offset, or a commercial way to introduce a market measure into the industry on a voluntary basis?
There's oftentimes kind of the question, right, arisen around how is this different from offset? And it's true that, this allows you to kind of claim green attributes without buying a physical product. And that is, similar to offsetting, but that's really where the similarities end.
That's Fredrik Jacobsen, project manager at the Copenhagen, Denmark-based Maersk Mc-Kinney Møller Centre for Zero Carbon Shipping. The centre has a growing number of experts looking at decarbonisation strategies, looking at the technologies and looking at the incentives. And one of them is the book and claim idea for shipping, which it wants to see trialled. Fredrik explains to me the difference between the book and claim system and an offset.
There's a couple kind of key differences to keep in mind. And, the first is that book and claim is a chain of custody model. It's tracking attributes through a physical supply chain, whereas offsetting isn't necessarily a chain of custody model. There might be offsetting mechanisms that are chain of custody models, but they're not all of them are. So it can be a bit of a gray area. So that's one kind of difference. The second difference is, where is the source of low emissions coming from? So in the book and claim system that we're developing, the low emissions are coming from ship companies using alternative fuels and only being purchased by people in the shipping supply chain. Whereas when you look for offsets, where is the source of those kind of low emissions coming from? It can come from anywhere. It can come from a forest not being cut down. It can come from a carbon capture project. So the source is anywhere, not necessarily the industry that you're in, and who can actually participate in the offsetting market? Well, anyone. And then final difference is, for offsetting, what you're generally buying kind of compensations for reductions. So you're buying avoided emissions or kind of removed emissions. And what we've seen the offsetting market today is most of the kind of credits that are bought are avoided emissions. And avoided emissions can be tricky to actually verify because you're basically saying in a hypothetical future, we would have done this activity, but we didn't. Therefore, we have saved something. And no one has a time machine and can say, yes, that is correct. So you just have to take their word for it.
So this is a tool to support early movers and ensure that vessels that are using more expensive fuels can receive additional income and support green growth.
What we have tried to do in this book and claim system that we're developing is said we're trying to avoid these kind of hypothetical scenarios where you say we would have done this and we didn't. We say what is kind of the basis for this is measured emissions, actual emissions. So you don't have this kind of issue that can arise with offsets.
Now, going back to how this book and claim approach differs from a generic offset and a hypothetical voided emissions, it's a key tenet even written into various guidance documents, including the Greenhouse Gas Protocol, which sets standards to measure and manage emissions, including Scope 2 and Scope 3 emissions. Within the GHG protocols, and I'll put a link to the protocols in the show notes, there is clear explanation of book and claim and how it should be different to an offset with its assumed and unverified emissions reductions. And knowing there are similar book and claim models in existence in other sectors and that there is a robust set of recognised protocols could be important for any potential book and claim system for shipping. It's also worth noting that these other systems can and do work in conjunction with emissions trading schemes and other offset initiatives and not against them. For example, the electricity focus scheme in Europe works alongside the industry being within the European emissions trading scheme. But as this proposed system for shipping would need multiple users to work and create a sort of market, it would need multiple ships, multiple ship owners, multiple cargo owners to test it out, and that would be the next stage.
One is there are companies who are investing in green shipping today, and they are struggling with this whole willingness to pay. So they might say that I can't find a cargo owner who is willing to pay. But it's true that, the starting part of the system, it could be a challenge to find the green shipping there. But we think from the companies that we've spoken to that, there are more and more companies investing in it, but they want to make sure that the investment that they made will be paid back and that they will be compensated. And, if it's not, then I can assure you that they will not continue those type of investments. So this is trying to kind of ensure that these first movers aren't penalized for thinking long term.
Frederick Jacobson, a project manager at the Maersk Mc-Kinney Møller Centre for Zero Carbon Shipping, about the book and claim system, which if it gets off the ground could allow cargo owners to claim green credits when they claim or buy emission certificates booked into a system by the ship operators of vessels using clean fuels. Now, the details of the system have yet to be worked out, and how grey and blue fuels such as even LNG or methanol and hydrogen fuels produced using hydrocarbons would be booked into a system alongside pure green fuels. But it is an early step to allowing first movers to feel more confident of the green fuel investments. Now, staying with clean fuels, those ships with clean fuels and new technologies still need crews on board. And those crews will obviously need training. Last week, a report came out complete with handy media-friendly graphics and statistics about the number of seafarers that need training or retraining. Hundreds of thousands of seafarers need to be trained to use new technologies. It's a simple math calculation to work out, really. Under certain possible scenarios, a certain number of vessels are expected to be built or retrofitted to run with new fuels and new technologies in the coming decades, and the crews who are on board them need to be able to operate them safely. The number of new vessels on new fuels could be lower if the decarbonisation curves are lower and slower, but more if the most ambitious of goals of decarbonising the shipping industry is achieved. Now, these ships will have a known number of seafarers on board, as written into the IMO regulations like SOLAS and the Maritime Labour Convention, and in particular the principles of minimum safe manning. And what seafarers should learn is prescribed in STCW, for example, the International Convention on Standards of Training, Certification and Watchkeeping of Seafarers, if you needed to know. The Maritime Just Transition Task Force commissioned DNV to understand just how many seafarers will need to have training and education on new fuels in the coming decade, to basically 2050. Now, the range is between 300,000 with a transition going on to 2050, that's assuming a slow transition, and 1.2 million where the transition is quick and actually up to the end of the 2030s. In that most dramatic case, where 1.2 million may need to be trained in the next 15 years, some questions will need to be answered quickly, such as how will the hundreds of training colleges around the world prepare for the demand, or what will they teach? Shipping still doesn't know which fuels will be popular on what trades, and it could easily be that there will be a scenario of multiple fuel options emerging. There are already basic courses on the handling of LNG as a marine fuel. There are also basic courses and type-specific courses on the use of ECDIS. One could also look back to how chief engineers used to go to sea with a steam ticket or a diesel one. Peter Nygaard-Hoffmann is a safety, risk and reliability expert at DNV and worked on the Just Transition reports to come up with these initial numbers to help policymakers understand the task at hand.
The most comprehensive training would be, of course, the engineers that would actually need to maintain and operate the different machineries needed. There could be some of these fuels need different types of engines. You talk about fuel cells as well, right? So it's a bit of a different way of maintaining the engines. Of course, also different properties of the fuels, different scenarios, different hazards involved in handling these fuels. So they would require that, but that also needs to be known and to the rest of the crew, right? Because these fuel has some different properties, and they would need some general, at least safety training to know how to behave if something happens on board, and they would need to know how these fuels behave and know how to mitigate those safety hazards.
If shipping is to be decarbonised quickly and the introduction of fuels and technologies happens quickly, then it stands to reason that the training structure should be in place even quicker.
You would need some updating, I would say, of STCW to detail how some of this crew training would be, and maybe put the baseline of what that would be. And we did also discuss in part that there are different part of the maritime industry today has experience with some of these fuels, maybe not as a fuel, but as a cargo, right? So you have ships transporting like hydrogen and ammonia and methanol and some of these alternative fuels that are coming along, right? So there might be some safety mindset you could use. Maybe you could even think about using some of those crew members to help you to train people on board. What we see on the numbers that we have is that some of these graphs, they show a quite significant tipping point. So there's very few ships maybe for a while, and then at some point the uptake will start, and maybe that's when the regulations really kick in. So you have, to a certain extent, some time, but at the same time, it depends on how fast the industry have to move. That at some point you might. So if you don't start today, at some point you might be way too late. So I think it's very important that we start looking at this today, and we do know a lot about it, and I think it's possible to start making some of that course material and training facilities and everything already today. And then, of course, also looking into the future, it will come. So the cadets and the crew members being trained today, sooner or later they will experience those kind of ships and those fuel types. So I think it would be wise to start today and not wait until you absolutely have to.
Peter Nygaard-Hoffmann, safety and risk expert at DNV, on the need to begin preparing to train existing crews and educate cadets on new fuels. Now, as he said, crews of the future will not only be expected to understand and be trained on the risks of using new fuels on board future tonnage, but also on those new technologies. Now, some seafarers today will have some experience in using scrubbers, ballast water treatment systems, maybe even onshore power connections and batteries, but it may soon find the needs to understand and have to maintain and overall hull fouling anodes, sonar systems, carbon capture technologies, integrated fuel cell and battery systems, perhaps even nuclear fueled, increasingly autonomous systems. But one technology that's beginning to emerge, or perhaps re-emerge, is wind power. Will seafarers be sailors again? More of that in a second.
You're listening to the Aeronax podcast with news, stories and voices about the changing shape of the shipping and ocean economies. Go to Fathom World to find out more, and don't forget to sign up for the newsletter.
It was only in the last episode that I talked about 9.5 million euros of funding from Horizon Europe for a maritime project to examine the opportunity to trial out how wind and solar can be combined, and now we've heard of another. It's another pot of over 9 million, so that's 18 million euros of European funding for wind projects announced in 2 weeks. This time for the Ocean Bird and Orcelle Wind project, the one that has been developed by Wallenius Line in Sweden and taken up with Wallenius Wilhelmsen in Norway, who had the well-known Orcelle concept vessel about 10 years ago, and of which, by the way, there is still a scale model on display in the entrance to the headquarters in Oslo, Norway. I spoke to Wallenius a year ago about the scale model of the Ocean Bird design that was built to begin looking at how a car carrier can be designed and built so it could be almost 100% powered by the wind. And if you look in the archives, you can soon find that interview. Now, things have developed over the months, including a somewhat dubious tie-up with ABBA brand. I'm not quite sure where that's coming from. But more importantly, with Alfa Laval, another Stockholm, Sweden-based company, but one more largely recognised perhaps for pumps, ballast water systems and boiler systems. And incidentally, it was Wallenius and Alfa Laval that worked together on one of the very first ballast water treatment systems. Ocean Bird is the name of the Wallenius Alfa Laval joint venture developing the wing concept, which will be an integral part of the Orcelle Wind design. Nicholas Dahl is a former Alfa Laval employee, now managing director of Ocean Bird. So it is his job to get as much out of the design as possible and bring the idea to market. So I asked him first how the funding will be used.
This enables us to do both a land-based full-scale testing, and it also enables us to do a retrofit installation to take step by step in order to have the best performance when we then go into the fully sailing ship. So the whole 9 million is a part of funding and working on how can we develop tools and how can we develop the wings, and also how can we optimize and work on the logistic. And then of course Ocean Bird, we are one part of this, and that part is then mainly to focus on the wing sales. So it's in total 11 different companies like research institutes, KTH from the Royal Institute of Technology in Sweden. And so it's a lot of different things into this complete Horizon project.
If you've been following the Ocean Bird's journey, you may recall that the wing sail design was initially going to be a massive 80 metres in height. But thanks to tests with a scale model that has been sailing around the Stockholm archipelago, the design is now smaller, more efficient, and importantly, it's now retractable. The Orcelle Wind project, part of the project, will look at the optimised vessel hull design, while the retrofit experiment will allow some of the wing assumptions to be tested, said Dahl, who also said that the whole project may be pointing to a new build design, but the wing sail itself can be used on existing vessels.
Of course, if you're doing a fully sailing ship, the hull has a bigger impact. I mean, both from a stability point of view and from a performance point of view in that, because then you can optimize it. But you still generate the same amount of thrust, even if you put the wing sail on an existing vessel. So you will still see a significant savings on those parts. So what we are talking about in our case is that we want to do a lot of savings on a few where we talk about the complete new buildings and fully sailing ship, but then it's even more savings on the retrofit. If you look into the whole market per ship, it will be less, but on the complete impact for sustainability, it will have a bigger impact on the retrofit. So that's why it's very important for us. If we want to revolutionize the shipping industry and work on this, we also need to address the 60,000 ships that are already out there sailing. So this will be one of the first for us, and you get, you generate the same amount of thrust, of course. So you can optimize a little bit more if you, of course, take care of all the hull and do everything from the beginning. But it's fully feasible to do it also on existing. Then regarding the savings, it's very difficult because savings is always depending on what kind of route you have. How much wind will it be? How much are you operating it? And a lot of things. But I mean, you could say in general, in this you will have around 7 to 10% savings on one wing sail.
The trial wing sail going on the car carrier is going to be 40 metres high with a 14-metre width. So it's going to have 560 square metres of area. That's all going to be retractable. The first Orcelle wing design was 80 metres higher, so they've halved the size while keeping the performance. So they've been working for the best optimum. Dahl said that there needs to be a balance struck between the optimum size of the wing system for performance, as well as the material costs, and also thinking about the sustainability of the system.
So it will be on one of the car carrier, it becomes natural because it's also, since they are also then working on the full ship, so then we can test together and we can take step by step and learning and working on that in order to get the optimum part. Then of course, I mean, from a wing perspective, it's also quite nice to start with a Ro-Ro. Every type of ship have their own challenges when it comes to retrofitting, but Ro-Ro vessel have the advantage that they have the bridge at the front, so you don't have any discussion about the line of sight. It's also quite high up, which means that you don't need to take care of green sea when the water is flooding over the deck and so on. Then of course, from the stability point of view and these kind of things, then and also the strengthiness of the ship, that is of course more challenging on a Ro-Ro or a car carrier. And that is what we have been working on now, how to do that in order to generate the thrust and how to go through all the hazards and so you don't end up with any problem for stability and so on. We have looked into how can we optimize the performance, make it smaller, because that is also an important part regarding the environmental footprint for different things. It also reduces cost because you have less material and so on. So this has been the development during this year, to look into how to take it from a concept and a research project to make it to a really feasible product that is interesting for the market.
So a land-based trial of the wing design by the end of this year, a single system installed on a Wallenius or WW vessel in 2024, and in the meantime the project will move into a more commercial phase with talks for potential customers that are ongoing. But there, Dahl was a little bit more cautious. He said it's still too early to pin down capital expenses in installing the Oceanbird design on an existing vessel, nor for the design of an optimised new building under the Orcelle Wind project. What of that scale model? The scale model that they had sailing around the Swedish archipelago over last year. Well, that's currently out of the water at the moment, just as most boats are in Stockholm during the winter so that they don't get frozen over. But it's likely to be put back into the water for more testing.
It's a great way for us to get more info, get more data and so on. It's more regarding how to operate it. So in that way we have not redesigned the wings on that ship at this point, but we might do that during the springtime. But it's not a test of the wing itself, it's more how we operate, how we automate and also testing different sensors like wind sensors and other things. How do you get the best performance out of it?
Nicholas Dahl, Managing Director at Oceanbird, the joint venture between Stockholm, Sweden-based companies, the ship manager and operator Wallenius Marine, and the technology company Alfa Laval. Now, before I end this episode, I want to tell you a little bit about a special mini-series of the Aeronax podcast I'm currently producing. I'm fresh back from spending a few days on Finnline's vessels in the Baltic Sea. Finnlines has RoPax and Ro-Ro vessels crisscrossing across the Baltic and even going further afield. I went from Sweden to Finland, then to Germany and back to Sweden on 3 different vessels, talking to the crew, hearing about their life as a seafarer today, about their thoughts for the future, about the Baltic Sea and the Finnlines vessels. It's just getting a bit light. But in front of me is the Europa Link, Finnlines ferry that's running between here and Naantali. And where do you tend to put them? Down on this lower deck here or up on the top?
Yeah, the ones that can stand inside, of course we put them inside because otherwise they will get full deck immediately. And some of them are not allowed to be inside. We can go to the cargo office.
All right, my name is Anton Stenback and I'm line pilot here at Europa Link. It's like a pilot-co-pilot system and it works pretty well here in the archipelago.
Well, I've now met up with Captain Pekka Stenvig, who is master of Finland.
Yeah, 85 I started on that ship over there and since then I've been at sea all the time. Well, this route of course we have quite exciting. We have plenty of warships nowadays and then we got the explosion of the gas pipeline. It's quite close to this place where we are
new
now.
Building food concept manager. Passengers at the moment on these old ships are 500, and on new ships it's 1,100 passengers. But about 200 are drivers, truck drivers. But yes, the new segment for Finnlines is passengers. We have many new restaurants.
That's some of the voices from my look at life at sea in the Baltic on Port Finnline's vessels, coming soon, and supported by Sea Focus International. Now, Sea Focus is behind the intelligence hunt concept, which brings together industry students with the drive to work in our industry and the corporates who understand the potential that working with such bright minds can bring. Intelligence Hunt is about bringing them together under expert mentor guidance to help solve real-world industry challenges. So look out for these 3 new episodes coming in the Aeronax stream in the coming weeks. So that's it for this episode. All these stories and more can be found on the Fathom World website. So go to fathom.world, sign up for the newsletter to stay in touch with the transformation of shipping and maritime industries, and feel free to get in touch with me. Until the next time, goodbye.